हेलो राहुल। राहुल मैं ना मेरी ऐप में तो क्लास है बट नॉट विजिबल ऑन यूट्यूब। यूट्यूब पे नहीं प्ले हो रही है। अर्पित से बात कर रहा हूँ बट अर्पित बिकॉज सेशन इज लाइव ऑन द ऐप। इट इज लाइव। नो इट इज हाँ हाँ हाँ। तो अर्पित को यार बोल दो मेरे पास नंबर नहीं है। आई डोंट हैव नंबर। मैं उसको स्लैक में बोला हूँ। स्लैक पे। और आई एम लाइव ऑन ऐप ऑल्सो। हाँ माई क्लास इज लाइव राइट नाउ। I'm really sorry for this inconvenience, my dear. Yeah, I will definitely continue. Don't worry. I will start, but actually, this is a multi-streaming session. So we are just checking what is the problem so that we can make it live on both app as well as on the YouTube. Don't worry, it will take just hardly few minutes. Yes, I think we are live on the YouTube also. So very good evening, everyone. Welcome to the session. I think we are live also on the YouTube. Okay. Hi Pratap, very good evening. Vishal, good evening. Venkat, very good evening. Yeah, I'm visible in the YouTube. So very good evening, Sunita, Saurabh, Rameshman, very good evening. So there was some issue in the session. That is why the session was not visible in the YouTube. But now this technical issue has been removed. So very good evening, everyone. Welcome to the session. Nitish Kumar, Sunita Yadav, Saurabh Vishwas. Very good evening. I'm live on YouTube as well as in the Gradeup app. So welcome everyone. I again welcome you all to this Vizag MT 2020 practice session on thermodynamics part 2. I'm Vikas Bhadoria and I welcome you all to this session. So yes, everyone quickly join me for this session. Those who are there in the YouTube, very good evening to all of you, and as well as those who are all in the app, very good evening to all of you. I welcome you all to this session. Those who are there in the YouTube channel, please take out some time to like the session, to share the session, and also please subscribe the channel and press the bell icon. Hi Varun Kumar, good evening. Kranti Gupta, very good evening. Mohan, good evening. Venkat, good evening. Good evening to all those who are there in the app. Okay. All right. Thank you so much. Thank you so much. Hi Shamila. Very good evening. Sharad Lal, good evening. Audio and video are okay. Both are fine. Shall we start, my dear? All right. So I think let's stop this waiting time. And I think we have 15 likes for the session. And we have 12 watching. What happened, guys? Please quickly join me on the YouTube as well as in the Gradeup app. YouTube पे live हो गया है वरुण. It is live now on the YouTube. You can join me on YouTube also, or if you want, you can join me on the app also, so that if any problem is there, you can also join me on both the interface on app as well as on YouTube. FM lecture will be tomorrow at 1 p.m. Due to some problem, the FM lecture has been postponed for tomorrow. Okay. So my dear, welcome to the session. I think it's right time to start the session. Those who are there in the YouTube, quickly, come on, quickly, just make this session, the number of likes, let's make it 50. And those who are in the YouTube session, just come on, just share this session and subscribe the channel. Come on, quickly, everyone. Okay, let's start the session. I'm going to start the session without any delay. So I would like to introduce myself first. I'm Vikas Bhadoria. One second. Yeah. Sorry. Yes, I would like to introduce myself first. I'm one second. Yes. So one second. Just wait 1 second. There's some problem with my notepad. Just wait 1 second. Okay, just wait 1 second. There's some issue with my notepad. Okay. So today, guys, we are going to solve many questions on thermodynamics. So just be with me for next 1 hour and trust me, you are going to enjoy a lot in this session. Okay. So shall we start? Okay. So I would like to introduce myself. My name is Vikas Bhadoria. I have 5+ year teaching experience. I did my MTech in thermal engineering from Thapar University. I have mentored more than 10,000 plus aspirants for different exams like GATE, Engineering Services, SSC, JEE, and my area of expertise includes subjects of fluid mechanics, thermal applied, and heat transfer subject. So let's start the session. This is question number 1. Those who are there in the YouTube as well as in the Gradeup app, let's answer these questions. Let's solve these questions on thermodynamics and let's make your preparation more strong for this Vizag Steel exam. This is a very important thing I want to tell you, that if anyone is preparing for UPPSC AE exam and Vizag Steel, then this session is important for both of the type of aspirants, because the type of questions are exactly same for Vizag Steel and UPPSC exam. So if you are following this session, then definitely it is going to help you for Vizag Steel as well. Okay, Saurabh has given answer A, Hariom Yadav A, Neeraj Kumar A, Nellore Ashok has given A for this question. All right. And Shubham has given A for this question. Those who are there in the YouTube channel, I can see Sharvan, Sharmila has given A, Shri Kumar has given A. Very good. It's a very simple question. Isentropic flow. Isentropic flow means adiabatic flow. It is also called as, one second. It is also called as adiabatic, reversible adiabatic flow. That is, in adiabatic flow, the heat transfer is 0, and in reversible flow, the entropy change is equal to del Q by T for reversible process. So in that case, the entropy change is 0, the entropy will become constant, and such a process is called adiabatic, and reversible process is called isentropic process. Very good, those who have given option A, very good. Next question. The entropy will usually increase when a molecule is broken into 2 or more small molecules. A reaction occurs that results in an increase in the number of moles of the gas. Process is adiabatic or process is reversible adiabatic. Yes, I hope the session audio and video is perfectly fine. Those who are there in the YouTube as well as in the app. Hi Ashwani, very good evening. Yes, you are online, so welcome to the session. Hi, okay. Yapan Engemer has given A, Sunita Yadav has given A. What is the answer for this question? What will be the answer for this question? Come on everyone, tell me the answer. Come on. Yes, quickly my dear, those who are there in the app and YouTube, please quickly answer the question. For this question, what is the answer? Yes, the entropy will usually increase when a molecule is broken down into 2 or more smaller molecules. A reaction occurs that results in an increase in the number of moles of the gas. Process is adiabatic, process is reversible adiabatic, a liquid changes to gas. So the answer will be yes. Come on, tell me. Entropy will increase in the case of, yes, the entropy is going to increase in the case of option C is the right answer, because process is reversible adiabatic. In this particular case, entropy will be constant. But in all the other cases, that is when a molecule is broken into 2 or more molecules, then entropy will increase. Okay, obviously the randomness will increase, the entropy will increase. A reaction occurs that result in an increase in the number of moles of the gas. This will also cause the increase in entropy. Process is adiabatic, that is heat transfer is 0. If heat transfer is 0, we cannot say that the process entropy will not increase, because in that situation, your entropy change is equal to del Q by T plus entropy generation. So maybe if your heat transfer is 0, maybe the entropy change can become equal to entropy generation. And entropy generation is always a positive quantity. Okay. So in this situation also entropy will increase. Entropy is not going to increase only in this situation when process is reversible adiabatic. So the answer will be option C. A liquid changes to gas, a phase change process. In the phase change process also, the entropy change will be del Q by T. Okay, so there will be an increase in entropy also when a liquid will be changing its phase to gas, because gases have more entropy, my dear. If you see liquid changing into gas, gases have more entropy because gases have more randomness. So obviously, when liquid will change into gas, the entropy will increase because randomness will increase. Okay, next question. Next question, tell me the answer for this question. What will the answer? Yes, today I got gold in the gate conduction. Very good, Ashwani. Very good. I'm so happy to see that you have got such a good rank in this gate conduction quiz. So I hope that you guys are going to option one explain kar dijiye. See, Hariom, actually, when a molecule is broken into small molecules, right? So when a molecule is broken into small molecules, that is only possible when the randomness will increase. Okay, when the randomness of the gas molecules will increase. Randomness will increase, so entropy will increase. What is the answer for this question? An ideal gas of mass m and temperature T1 undergoes a reversible isothermal process from an initial pressure of P1 to a final pressure of P2. The heat loss during the process is Q. Then the entropy change of the gas will be. Yes, what will be the answer for this question? Ashwini has given C, Jenny Bella has given C for this question. And many students are giving option B in the app. Hariom Yadav has also given option B. Very good. Those who are given option B, that is the right answer. You know that entropy change for an ideal gas can be given by these relations Cp log of T2 by T1 minus R log of P2 by P1. Okay, because we are basically finding the entropy change for an ideal gas with respect to the pressure. And with respect to pressure, at constant temperature, at temperature is constant, then T1 will be equal to T2, then this portion will become log 1. So the entropy change will become Cp of log 1 minus R log P2 over P1. It's a very simple question, but this is 0 because log 1 is 0 minus R log P2 by P1. Minus R log P2 by P1 is equal to R log P1 over P2. Okay, got it? So the answer will be option B. Okay, now if you have to find the total entropy change, you have to multiply with m also, because we have to find the total entropy change, not a specific entropy change. So it will be mr log of P1 by P2. Okay, so the answer will be option B. Very good. Those who are there in the app, in the Gradeup app as well as on the YouTube channel, you guys are doing excellent. Very good. Okay, you just type wrong. My dear Ashwin, don't do that. Just type whatever is the correct. Okay. The heat loss during the process Q. See, that heat loss, Naga Venkat, is actually causing the entropy change. That heat loss is the one that is causing the entropy change. And because of that, the entropy change relation for an ideal gas, as you know that, the heat loss is actually which is causing the entropy change. So that is the entropy change relation you know about an ideal gas. You basically have studied two relation S2 minus S1 is equal to Cp log of T2 by T1 minus R log P2 by P1. The second one is Cv log of T2 by T1 plus R log V2 by V1. So we have to use that relation. The entropy increase of the solid substance as it melts into liquid at 27 degrees Celsius. The latent heat of the fusion of the substance is 400 kilojoule per kg. So those who are there in the app, they are giving option D, Ashwani, study hard, Saurabh, very good, Nellore, Ashok, very good. Those who are there in the YouTube, Sharmila, Saurabh Vishwas, Nitish Kumar, Giraj Singh is given B, Ramishman is giving D. Very good, Nitish Kumar, D. Prashobh is giving D. Very good. So the answer for this question will be option D. The entropy change will be equal to the heat transfer divided by saturation temperature, because when phase change take place, that heat transfer is equal to latent heat. The heat transfer is latent heat. So the entropy change will also be equal to latent heat. Why this formula? Because a phase change process is isothermal process. A phase change process is isothermal, and for an isothermal process is a reversible process, and for a reversible process you have to apply this equation, my dear. Okay, and that will be 400 divided by saturation temperature is 300, that is 300 Kelvin. So you'll be getting 1.33 kilojoule per kg Kelvin. Next question. A system of 100 kg of mass undergoes a process in which its specific entropy increases from 0.3 kilojoule per kg Kelvin to 0.4 kilojoule per kg Kelvin. At the same time, the entropy of the surrounding decreases from 80 kilojoule per kg Kelvin to 75. You have to tell the process is reversible and isothermal, or it is irreversible, reversible only, or isothermal only. What will be the answer for this question? Come on, tell me everyone. Yes. I can see in the Gradeup app, many students are live and they are doing very well. And the same in the YouTube also, those who are there in the YouTube channel, if you are coming, those who have joined me for the session, please like the session also and share the session to many students. So those who are preparing for YJAC Steel exam. Yes. So what will be the answer for this problem? Tell me. Study hard in the app. Your name is study hard, so you must be studying very hard, I think. I hope that. Shivam is giving B. Saurabh is giving option B for this question. And those who are there in the YouTube channel, I can see many students are responding, but Jai Krishna has given D and Sarvan has given D for this question. Is it D for this question or the previous question? So are you guys giving the answer for the D for this question or previous? Varun Kumar has given C. Ashwani has given B for this question. Okay, so guys, it's a very simple question. How you are going to solve? Sarvan has given B. Sharmila has given B. Dhirendra Kumar has given B. Jay Surya has given option B for this question. Yes, Shrikant has given option C. Nitish Kumar has given option B. Yes, the right answer for this question will be option B. And those who have given option B, that is absolutely correct. Very good, my dear. So, my dear students, if you see that the total entropy change is equal to entropy change of the system plus entropy change of the surrounding. Now, the specific entropy increases for the system from here to here. So, we can say that total specific entropy change will be equal to S2 minus S1 for system. That will be equal to 0.4 minus 0.3. Okay, so that will be 0.1 kilojoule per kg Kelvin. But we have to, they have also given the mass, the total mass also given 100 kg. So the total entropy change will be equal to m into S2 minus S1. That will give you 100 into 0.1, which is 10 kilojoule per Kelvin. While entropy change of surrounding is equal to, it is decreasing from 80 to 75. So that will be 75 minus 80, which will be minus 5 kilojoule per kg Kelvin. Okay, it will be, yeah, that will be 80 kilojoule per kg Kelvin. Entropy of the surrounding is, I think this unit is something different, that is not correct. It has to be in kilojoule per Kelvin, I guess. Kilojoule per Kelvin, I think. It has to be in kilojoule per Kelvin. Yeah, kilojoule per Kelvin it will be there. And this is in kilojoule per kg Kelvin. Okay, so you can find the total entropy change. The total entropy change will be equal to 10 minus 5, which will give you 5 kilojoule per Kelvin. And because this is coming out to be positive, entropy change is coming out to be positive, that is only possible for a irreversible process. In only that case, the total entropy change of system plus surrounding is called entropy change of universe. And entropy change of universe, if it is coming out to be positive, that is only possible if the process is irreversible process. Okay, because if it had been reversible process, then entropy change of universe will be what? What will be the entropy change of universe? It will be 0, because for reversible process, the entropy generation will be 0. Entropy generation will be 0, and if it is universe, then heat transfer is also 0. In that case, the entropy change of universe is 0 for a reversible process. Okay, and for irreversible it will be positive. This is also called increase in entropy principle. Next question. Two reversible engines are connected in series between a heat source and a sink. The efficiencies of these engines are 60%. Yes. For negative, it will be impossible. Exactly. If that comes out to be negative, then in that case, it will be impossible. Okay. Yes. Tell me the answer. I had told earlier. No, that was a mistake in the unit. That unit has to be actually, that unit will be kilojoule per Kelvin for surrounding. Okay. What will be the answer for this question? If you know the direct formula, you can easily solve this question. Yes. No, for irreversible, Nithaji AM, for irreversible process, the entropy change will be positive. Okay. and for reversible it will be 0, entropy change of universe. So increase in entropy principle also tells you that all those processes are possible in second law of thermodynamics for which the increase in entropy principle, that is for reversible process, entropy change will be constant, and for irreversible it will be positive. For this question the answer will be option C. Very good. If two reversible engines are connected in series, their efficiencies are given 60 and 50, then the combined efficiency will be equal to efficiency of the first engine plus second engine minus of efficiency of first into second engine. That is a direct formula. So it will be 0.6 plus 0.5 minus 0.6 into 0.5. Okay, so that will be 1.1 minus 0.30. That will be 0.80. That is 80%. Okay. Vizag Steel exam is tough. Oh, actually, the level of questions of Vizag Steel are little bit not tough. See, the level of question will be little bit close to engineering services, little bit close to UPPSC AE exam, and also close to ISRO exam. Okay, so you cannot say it is actually tough, but yes, there will be some calculation based question also. Availability function for a closed system is expressed as, yes, exactly, Ramesh Mohan, exactly, that is correct. Very good. Saurabh Vishwas has given 60 plus 50 minus 60. Yeah, okay, that is correct. Very good. Yes, those who are there in the YouTube channel, please do not forget to like and share the session, because sharing is caring. You must have heard about this wonderful saying that if you really care about someone, then please share your feelings with them. So if you think that this session is important for anyone who is preparing for Vizag Steel exam, you can also share this session. Okay. Saurav Vishwas is saying, sir, please conduct a class on detailed NLC answer key. Saurav Vishwas, that okay, I have taken your suggestion. I will ask my team regarding that, and let's see what can be done regarding that. Okay, don't worry, because that has to be actually decided by the team also, that whether the session will be conducted or not. Nellore Ashok Ashwani has given A. Hariom Yadav has given A in this app. Nitish Kumar has given B. Saurav Vishwas has given B. Yappan has given B. Sri Kumar has given B. Very good, very good. Those who have given, the answer for this question will be what? Yes, availability function for a closed system is U plus, what is the answer? U plus P naught V minus T naught S. So that will be the answer for this question. That will be equal to, see, for a closed system, the availability function is equal to U minus T naught S plus P naught V. This is the surrounding work, my dear, surrounding work in closed system, which is a work done by the system on the surrounding, or if it is a compression process, that is work done by the surrounding on the system. But if this, in case this is neglected, then this function will also become equal to U minus TF. This will become Helmholtz function. This will become Helmholtz function, which is also availability function of closed system. For this question, the answer will be option A. So those who are given option A for this question, it is absolutely correct. Very good. Next question. Which of the following represent the unavailability? Which of the following represent unavailability? See, it cannot be option B, Nitish Kumar, because they are asking about the availability function. Availability function is always given like this. Okay, U plus something like that. And if you have to find the maximum available work from availability function, that will be equal to phi1 minus phi2. Okay, so that will become U1 minus U2 minus T naught of S1 minus S2 plus P naught of V1 minus V2, something like that. Okay, but that is maximum available work. They are only asking about the availability function. Availability function is different. It is just a function. This is the availability function. Okay, so the answer will be option A. Next question. Which of the following represent the unavailability? Ramesh Kumar has given C. Dheeraj Sardana has given A. I can see in the app, Jenny Fela Naga Venkat Ramji has given. Okay, Ramji, I will call you Ramji. Okay. Yes, for this question, the answer will be T naught into delta S. Okay, Yes, very good. Yes, the answer will be T naught into the entropy change. So what is the answer? The unavailability function is equal to T naught into entropy change. So that answer will be option B or option C. Tell me. It will be option C. The unavailability function or irreversibility is equal to T naught into entropy change. Actually, has to be entropy change of universe. That is, this is also called Gauss-Toedler theorem. Gauss-Toedler theorem of irreversibility. According to that, total irreversibility is equal to T naught into entropy change of the universe. Yeah, exactly. It is Gauss-Toedler theorem. Very good, Rameshman. Yes, those who are given option C for this question in the app and in the Ashwini, yes, you have given correct. Very good, Ashwini. Nelo Ashok has given correct. Study hard. And Nitish Kumar. Last, Sharvan has given correct. Abhishek Mandal has given correct. Sharat Lal correct. Dheeraj Singh Jadam correct. Very good. Very good. Next question. What is the loss of available energy associated with the transfer of 1000 kilojoule of heat from a constant temperature system at 600 Kelvin to another at 400 Kelvin when the environmental temperature is 300 Kelvin? It is a direct formula based question. If you know how to find the loss in available energy when there is an engine which is exchanging heat with two different types of reservoir having two different types of source temperature, while the sink temperature is common, that is the surrounding temperature. In that situation, there will be a loss in available energy. For example, let us say this case, we are having a heat engine. One is operating at a temperature of 600 Kelvin and it is taking some heat of, let us say, 1000 kilojoule. And this engine is doing some work, let us say, and it is rejecting its heat to a sink 300 Kelvin. So this is the temperature of the surrounding, right? Another heat engine we are having this temperature is 400 and it is also taking same kind of heat, same quantity of heat, but it is rejecting the heat to 300 Kelvin. Obviously, there will be some loss in available energy. If you see, the maximum work in this case and this case will be different. And the difference of the maximum work, in this case, the maximum work will be equal to, this will be Q into 1 minus T naught by T1. That will be Q, that is 1000 into 1 minus 300 by 600. And in this case, the maximum work with W2 will be equal to 1000 into 1 minus 300 by 400. You have to find W1, then the loss in available energy. The loss in available energy will be equal to the answer will be option B. Very good. Those who have got option B, very correct. Absolutely correct. Very good in the app as well as in the YouTube. Those who have got option B as the answer, Hariom and Study Hard and Ashwani, they all have got option B. Nalor Ashok has got option B. And if I'm not able to take anyone's name, then do not get offended because I have to manage the comments of both YouTube and app. So maybe sometimes I'm not able to call name of all the students. So do not take that sir is not calling my name intentionally. No, I'm not doing it intentionally because I have to take name of everyone. Chahat has also given correct. Very good, Chahat. Sharvan has given B. Very good. So the answer will be B. So in this case, it will be W1 minus W2. You can find this. You will be getting 250 kilojoule. There is also a direct formula for loss in available energy. It is T naught into Q, 1 by lower temperature minus 1 by higher temperature. This is a direct formula. So you can just simply put 300 into 1000. You will be getting this is 1 by 400 minus 1 by 600. If you solve it, you'll be exactly getting 250 kilojoule directly. Okay, so that is direct formula. If you can remember that. Otherwise, you can use this method also. Next question. A heat engine receives heat from a source at 1200 Kelvin at the rate of 500 kilowatt and rejects the waste heat to a medium at 300 Kelvin. The power output of the heat engine is 180 kilowatt. What will be the irreversibility of the system? Come on, everyone. Yes, come on. I know you guys can do this. You guys are excellent. You can do this. You can solve this question. And I can see in the app, in the YouTube channel, those who are there, please come on. Please share this session and also please like the session if you think that this session is useful for you. How was this on YouTube? In the YouTube also, Ashwani, it is live. You can join me on YouTube as well as in the app. What is the answer for this question? In this case, you have to find the irreversibility of the system. There is a heat engine which receives the heat from a source at 1200 Kelvin at the rate of 500 kilowatt and rejects the waste heat to a medium at 300 Kelvin. The power output of the engine is given 180 kilowatt. So what will be the irreversibility? Now, in this question, you will be using one more formula for finding the irreversibility. So what will be the answer? Giraj Singh Jadon has got B, that is 340 kilowatt, and Ashwani has got 195. Yes, what will be the answer for this question? Please tell me. What will be the answer for this question? Tell me, everyone. Yes, Ashwani has got 195 as the answer. That is option A. Varun Kumar has got 320 kilowatt. Yes, those who are there in the YouTube channel, please answer this question. What is the answer? Hariom Yadav has got option A. Saurav Biswas has got option A. And yes, exactly Ramji. That is correct formula. Chanda Podar has got option B. Saurav has got option A. See, irreversibility, I have told you one formula, but there is one more formula for irreversibility. If sometimes in the question it is possible that they can ask you that there is a heat engine, and for that the heat engine they can give you the work output, and then they will ask you find the irreversibility. So that work output is actually the actual work. So they have given the actual work of this engine, that is 180 kilowatt. Irreversibility in that case will be equal to maximum work minus actual work. How can you find the maximum work for a heat engine? For maximum work will be equal to Q into 1 minus T naught by T. Or that is equal to T naught. In this case, the T naught is given as 1200 Kelvin and 300 Kelvin. So you can find this is 500 into 1 minus 300 by 1200. So you can solve this value, you will be getting the maximum work output from here. Okay, so that will be 500 into 900 by 1200. So this will be equal to 9, 3, 4, 12, 2, 250 and 2, 125. Okay, so what is the answer? What is the value of the maximum work coming out? 375. It will be 375 kilowatt. You will be getting maximum work at 375 kilowatt. So that will be equal to 375 minus 180, which will be equal to 195 kilowatt. This will be the irreversibility in this situation. Okay, so I hope all of you have understood these two types of question. You can find the irreversibility by using the Gauss-Todla theorem also. You can also find the irreversibility by the formula of loss in available energy. You can also find the irreversibility by using this formula. But all these formulas depends on the type of questions. Okay, it will depend on the type of question asked in the exam. Okay, next question. The maximum work output from the two finite bodies, one at temperature T1 and the other at temperature T2 is. What is the formula for maximum work output for two finite bodies, one at temperature T1 and the other at temperature T2? Yes, exactly. Ramesh Mohan, that is correct. Sarvan is correct. Chahat is correct. Very good. Nitish is giving yes. What is the answer for this question? Come on, everyone, be quick. Those who are there in the app and in the YouTube, please join me. And also, please, if possible, please like the session. If you like the content, and also share the session. Yes, what is the answer for this question? Ashwani has given option A for this question. Hariom Yadav has given A. Ramji has given A. Saurabh has given A for this question. The answer is Nitish Kumar has given A. Sarat Lal A. Chandan has given option A. Very good. Chahat has given option A. Very good. So there are two cases in entropy. Entropy during maximum work output. What will be the entropy during maximum work output? If you are getting maximum work output from any device or any engine, in that case the entropy change will be 0. In that situation, your temperature T2 will become root of T1, T3, or root of minimum and maximum temperature. In that situation, the maximum work output will be given by this formula. It will be equal to Cp of root of T1 minus root of T2 square. Okay. Actually, they are writing T1 and T2. Yes, you can take it T1. Let us say this is T. This is T1, T2. Okay. The answer will be same exactly. Okay. But you have to remember the concept. And in case you have to find the maximum for zero work, the entropy change will be maximum. And that entropy change will be equal to mCp m1c1 log of T final by T1 plus m2c2 log of T final by T2. So when a mixing of two incompressible fluid take place, so there are two cases. In one case, in mixing, you will be having zero work, and in the zero work condition, you will be getting maximum entropy. And that will be the formula for maximum entropy. You have to find the final temperature in that situation. That final temperature will be equal to m1c1t1 plus m2c2t2 divided by m1c1 plus m2c2. Okay. And this is another case. Okay, next question. For a steady flow process, the condition at the stage 1 and stage 2 are given. The enthalpy is equal to 300 in enthalpy at the two condition, entropy given. You have to find the availability at the ambient temperature 300 Kelvin will be. Is it D? Is it D for which question? No, it is not D. It is option A. Rameshman, you have given, I think already you have given option A for this question. Okay. Yes, exactly. Same thing you will be getting in Otto and Brayton cycle. In Otto and Brayton cycle also, the maximum work output formula comes out to be exactly same, like very similar to this. Okay. Yes. No, that is not arithmetic mean minus geometric mean. T1 plus T3. Yeah, exactly. Rameshman, you will be getting the same answer. It will be Cp into arithmetic mean minus geometric mean. Ultimately, you will be getting the same answer. No, but that is not the formula. In that case, you'll be getting half outside. No, that will not be half outside. Okay. What is the answer for this question? Nitish Kumar has given A. La Uchiha, that has given 15. Option A. Yes, exactly. Hariyam Yadav, that is correct. Very good. Those who are there in the YouTube, today's first class, so Mustaq Alam, I welcome you all to welcome you to this session. Yes, in the case of Brayton cycle, we take maximum and minimum temperature. Exactly. What is the answer for this question? The answer will be option A. Those who have solved this question, the availability is also called maximum available work. It is also called maximum available work, and that will be equal to H1 minus H2 minus T naught of S1 minus S2. So just put the value. You'll be getting this value as, it will be H1 minus S2 minus T naught of S1 minus S2, or it will be T naught of S2 minus S1. Tell me. Yes, it will be H1 minus S2. That will be 300. That is will be 150 minus 300 into 1.25 minus 0.8. Yes. What will be the answer you will be getting? The answer will be 15 kilojoule. Okay. Sir, his last question is similar to mixing. Yes, the last question is similar to mixing case. Okay, next question. The equation which perfectly represents the Gibbs phase rule for a process where the pressure is also a variable. If you are having both pressure and temperature as the two variables or two constraints, then what is the Gibbs phase rule? So you know that Gibbs phase rule is P plus, yes, what is the formula for Gibbs phase rule? Ashura has given A for this question. Yes, what is the answer for this question? Those who are there in the YouTube, hi Gaurav Bharti, very good evening. Welcome to the session. Yes, to everyone, those who are live on the YouTube and in the app, welcome to the session, those who have joined me right now. And Nitish Kumar has given D for this question in the YouTube. And exactly, yes, that is correct, Lalita, that is correct. Shiv Kumar has given D. Hariom Yadav has given B. Yes. So if there are two variables, in case you are having two variables of temperature and pressure, then your Gibbs phase rule will be P plus F is equal to C plus 2. This will be the Gibbs phase rule, where P is the number of phases, F is the degree of freedom, C is the number of component. Okay, and two constraints are there, two constraints. I hope you know that on critical point, at critical point the Gibbs phase rule fails, and at critical point your Gibbs phase rule is P plus F is equal to C plus 1, because one variable will be constant in that case, either pressure or temperature. Okay, which relation defines Gibbs free energy? Tell me the answer quickly. Yes, those who are live in the app as well as in the YouTube channel, please follow me. Tomorrow also I'll be taking one session on Vizag Steel session on thermodynamics, part 3. And in that session we'll be solving some questions on refrigeration and power plant. Today we'll be solving the questions on IC engine and thermodynamics. So yes, come on guys, be quick. Logan has given option B, Varun Kumar option B, Bhargav has given option A, Pranaya has given option B, Shivam has given option B for this question. Yes, it is equal to Gibbs free function is equal to G is equal to H minus Ts. It is also called availability of open system. All right, very good. Next question. A sample of ideal gas has an internal energy U and is then compressed to 1/2 of its original volume while the temperature stays the same. What is the new internal energy of the ideal gas in terms of U? यूपीएससी का देखिए चाहत यूपीएससी एंड यूपीपीएससी and Vizag Steel, the level of question is almost same in both the exams. If you see the level of question, the technical for technical the level of questions are exactly similar. So if you are practicing the questions of Vizag Steel, you can think like you are practicing the questions for UPPSC also. Yes. What is the answer for this question? Varun Kumar has given U, that is A. Bhargav has given A. Varun Kumar A. Ashwani has given D for this question. Okay. Nitish Kumar has given A for this question. Chahat has given option A. Very good. In the app, sorry, in the YouTube, it is very difficult to manage both the things. Okay. So the answer will be option A, because in this case we are having an ideal gas, and if the ideal gas is compressed, no matter if we are having an ideal gas and we are having internal energy of an ideal gas, what is the formula for internal energy of an ideal gas? U is a function of temperature only. Okay, it is a function of temperature only, so it is not going to get affected by the change in volume or anything else. Okay, so whatever will be the internal energy, it will be same. It is not going to be affected by change in the volume, because temperature is remaining same. Because temperature is same, so for an ideal gas, internal energy will also be same, because it is a function of temperature only. The part 3 timing Sarath will be at 7 p.m. Tomorrow the class will be at 7 p.m. Okay, the last lecture of thermodynamics will be at 7 p.m. not at 9 p.m. Today actually I have shifted to my different location. Basically, after many long time, I have now moved from my home location to my office location. So now basically that is because of some reasons I have shifted my class to 9 p.m. today. But tomorrow, from tomorrow onwards, the class timings will be exactly at 7 p.m. Okay. Chandan further has given option A. Rameshman has given option B for this question. For ideal gas, the compressibility factor. What is compressibility factor? The compressibility factor is equal to PV by RT. For an ideal gas, the answer is option B. For an ideal gas, the compressibility factor Z becomes 1. Okay, it is equal to Z is equal to PV by RT. And if Z is greater than 1 and Z is less than 1, that is compressibility factor, then in that case it will be a real gas, not an ideal gas. So for a real gas, the compressibility factor is greater than less than 1, and for an ideal gas, the compressibility factor is equal to 1. So those gases which deviate from ideal gas behavior, for example, Hydrogen and helium. Hydrogen and helium, they have positive deviation from ideal gas. While some gases like carbon dioxide, methane, these gases they have got positive and negative both the kind of deviation. So they will be having both negative deviation and positive deviation from ideal gas. Next question, which of the following relation defines the Helmholtz function? Quickly tell me the answer. Okay, I can see in the YouTube I have 24 students who are live right now. So I hope you guys are enjoying the session. And those who are live, please also take some time to like the session. And I can see there are 2 dislikes also. I don't understand. I hope this session we are solving some good questions for Vizag Steel, and I hope these session are not harming you. And these questions also not basically uh, taking something away from you. They are obviously they are giving you something. So definitely you are learning something in this session. So if you are learning something new, then you can like this session instead of disliking. Okay, इसीलिए आप ऐप पे भी हैं और उस पे भी हैं. Okay, that is very good, Ashwani. That is good. Okay, so what is the answer for this question? I can see Shahat has given option yes. Shri Kumar has given D. It is very simple. I just told you also that Helmholtz function is equal to U minus Ts. That is option. Helmholtz function, it is not H minus Ts. Helmholtz function is equal to U minus Ts. It is also called availability of closed system. Okay, the answer is option D. Next question. In a single component condensed system, if the degree of freedom is 0, then maximum number of phases that can coexist is. They are from electrical branch. Yeah, maybe there may be some from other branches. That is why. See, for these practice sessions, we are providing you this practice session. We are selecting these good quality questions for the practice, and so I think you should appreciate that effort. And for that, I think we deserve some likes, right? Not dislikes. I hope that. Okay. Those who are there in the app, yeah, Gibbs free energy. Yeah, B is the Gibbs free energy. This is H minus Ts. This is Gibbs free energy. It is G. Okay, it is availability of open system, and this is F. It is Helmholtz function. For this question, the answer will be what? Chahat, you have given D. Nitish Kumar has given D for this question. Yes, that is correct. Option D. Those who are there in the app, I can see Ashwani has given D. Hariom Yadav has given D. Varun Kumar has given D. Very good. Those who are there in the app. See, again, I would like to tell you that Saurabh Vishwas has given D. Nitish Kumar D. Very good. So you can see it is a single component system. C is equal to 1. Degree of freedom is 0. So if P plus F is equal to C plus 2, if this is 0, so this P will be equal to 3, right? So next question, which of the following option can always be approximated to be an ideal gas? To be an ideal gas. In which case you can call, which of the following can be approximately called as an ideal gas? That is the meaning of this question. Which of the following can be approximately called as an ideal gas? Highly superheated vapor, dry saturated vapor, supercritical fluid, or saturated vapor? What is the answer for this question? Come on everyone, tell me. Yes, I know that you guys will know the answer for this question. And your preparation is very good. I can see that Parvati has given A, Shubham has given A, Ashwani has given A for this question. Last has given 3, Sarath Lal has given 3, Kiran Singh has given C. Okay, so the answer will be option A, highly superheated vapor. Superheated vapor approximately behave as an ideal gas. Not exactly. Approximately they behave as an ideal gas. Okay, next question. It is not option D. Some of the students are saying option B, D. Well, Sheshatri Naidu, the answer is not option D. It is not saturated vapor, but it is actually superheated vapor which behaves as an ideal gas. A positive value of Joule-Thomson coefficient of a liquid means temperature drops during throttling, temperature remains constant, temperature rises during throttling. What is the answer? Positive value of Joule-Thomson coefficient. So you must have seen this experiment done by Joule and Thomson together. Joule and Thomson were 2 scientists. They have done Joule-Thomson experiment and they have done throttling experiment for a real gas. So when they have throttled a real gas, they have found that they have got 2 reasons. This is inversion curve. Okay. They have got found two reasons. In one region, the temperature was rising because in throttling process throughout the pressure will decrease. The pressure is going to decrease throughout. It is a graph of temperature versus pressure. Joule-Thomson coefficient is equal to temperature by pressure at constant enthalpy. This is called Joule-Thomson coefficient. So the answer for this question is if the positive value is only possible if the temperature drops during throttling. Very good. Those who have given option A for this question. Very good. Varun Hariom has given C. Bhargav has given A. Well, for this question it is not temperature rises. See, initially up to inversion curve, temperature will rise. And when it will rise, Joule-Thomson will be negative, not positive. Why? Because one is negative, one is positive. Obviously, this will be negative. And if you further throttle a real gas within the inversion curve, then you will see temperature start to decrease. So if one is both are decreasing, then Joule-Thomson will be positive. So this is also called as cooling region. This is also called cooling. This is called heating or warming region. Okay. Next question. Which one of the following properties remain unchanged for a real gas during a Joule-Thomson process? Which of the following quantity remain unchanged for a real gas during Joule-Thomson experiment or process? Come on, tell me the answer quickly. Yes, everyone. Yes, everyone, be quick, guys. We have to solve question of IC engine also today, and tomorrow we'll be solving question of refrigeration power plant. Okay. Yes, quickly answer me for this question. What is the answer? Which of the following properties remains constant? Yes, everyone. Those who are there in the app and as well as in the YT channel, that is YouTube channel, please answer the question. This question is really very important. It is really very important that which of the following property remains constant during throttling process? In real gas Joule-Thomson process, that is a throttling process, it is also called throttling. And throttling, my dear, you know that it is an isenthalpic process. Enthalpy will be constant. Enthalpy will be constant in that process. Okay. Next question. The dryness fraction of the steam is equal to. What is the formula for dryness fraction of the steam? Yes, tell me. Yes, Ashwani, Shrikant, you have given correct. Gaurav has given option C. Okay, Gaurav and Shrikant has given option C. No, that is not option C. It is option B, my dear. Yes. Naga Venkat has given correct. Those who are there in the YT channel, I can see Chahat has given option B, Thiagu has given option B, Saurabh has given option B, Sarath has given enthalpy, Nitish has given option B, Sri Kumar has given option B, Ashu Rai has given option B, Giraj Singh Jadhav has given option B. What is the answer for this question? Ramesh Mohan has given option B. Yes, the answer will be the dryness fraction of the steam is equal to, if mg is the mass of dry steam and mf is the mass of wet steam, then what is the dryness fraction formula? It is option A. It is equal to mass of the dry steam divided by mass of dry steam plus not mass of liquid water. No, it is not mass of liquid water. It is mass of wet steam. It is called mass of wet steam because if you have to find the dryness fraction of phase change of water, then in this particular portion, you can see that the dryness fraction in any situation is equal to mass of the dry steam. The percentage of dry steam divided by the total dry steam plus wet steam, that is called dryness fraction of steam. Okay. So it will be option number B. Sorry, option number A, not B. Next, region inside the inversion curve is represented by. Region inside the inversion curve is represented by. What will be the answer for this question? 100% correct till now. Yes, you can calculate your score also. I think that many of you have given all the options correct. So kudos to all of you, those who have got correct all the questions. So I think your preparation is really very good. And those who are doing some small mistakes, you still need some improvement, my dear. You still need some improvement. Okay, so you have to just take care of your shortcomings. Okay, and try not to repeat it in the exam. Bhargav has given option A, Rameshman has given option C, Shubham has given option A for this question, Giraj has given option A, Ashurai has given option A, Nitish Kumar has given option D. Region inside the inversion curve. See, if this is your inversion curve, this is your inversion curve, this is your inversion curve. Inside, not outside, inversion curve inside region. This region, it is having positive Joule-Thomson coefficient. This is cooling region and Joule-Thomson coefficient will be positive. So the answer will be option number C. Next, are constant pressure lines in the superheated regions of the Mollier diagram have what type of slope? Constant pressure lines in the superheated region of the Mollier diagram have what type of slope? Positive slope, negative slope, zero slope, or may have either positive or negative slope? What will be the answer for this question? ये आपने सिर्फ which book do you prefer for Vizag Steel? Well, Bhargav, for Vizag Steel, if you want to practice some good questions, then I think you should solve the previous year GATE questions, 1 marks questions, engineering services question, and UPBSC AE level questions. Okay, and ISRO level also. Okay, so if you want, you can solve these previous year questions. Sharvan has given option C, Srikumar option C, Saratlal option C, Chandan has given option C, Sai Kiran option C, Nitish has given option A, Chahat has given option A. Yes, the answer will be option A. If you see, Mollier diagram is enthalpy and entropy diagram. Okay, so on the enthalpy entropy diagram, you will be getting a graph like this. These are constant pressure line. This is a superheated region. So the superheated region, the region of a Mollier diagram is enthalpy versus entropy at constant pressure. This is the slope of the Mollier diagram and it is equal to absolute temperature. Now, my dear, if you go in the superheated region, the temperature will be positive. Why? Because it is a superheated region. And if temperature is positive, then the slope, which is equal to this, slope is directly proportional to absolute temperature. So the slope will also be positive. Okay. Next question. If compression ratio is kept same, then thermal efficiency of Otto cycle is less than the dual cycle. It is same as for diesel cycle. It is less than for diesel cycle. Otto cycle is more than that of diesel cycle. If the compression ratio is same, so this is a question which comes in many exams. Okay. No, it is not in temperature entropy, it is enthalpy entropy. Okay, Mollier diagram is a graph between enthalpy and entropy, not temperature entropy. Okay, what is the answer for this question? What is the answer? Come on, tell me. Chandan has given option A, Otto is more. Ramesh Mohan has given option Otto is more. Yes, Otto cycle has more efficiency than diesel cycle because at same compression ratio, always remember, at same compression ratio, Otto cycle is most efficient. Okay, always remember that. And at all other parameters, at all other conditions, diesel cycle is most efficient. Diesel is most efficient cycle. Okay, remember that. Next question. Efficiency of the diesel cycle depends on. Yes, efficiency of diesel cycle depends on. Efficiency of the diesel cycle depends on what? Tell me. Compression ratio and cutoff ratio, compression ratio, cutoff ratio, or cutoff and pressure ratio. What is the answer for this question? Sarat Lal has given option D. Saurabh Vishwas has given option D. Yes, what will be the answer for this question? Efficiency of the diesel cycle, if you know the formula, it is equal to 1 minus 1 by R over gamma minus 1 into gamma times of cutoff ratio over gamma minus 1 over cutoff ratio minus 1. This is the formula. So the efficiency depends on compression ratio and cutoff ratio, right? So if compression ratio increases, the efficiency will increase. But in case if cutoff ratio increases, then efficiency will decrease. So you have to remember this relation also. Okay, those who have given option B, that is absolutely correct. See, now I don't have actually because of सर ऐप पर ध्यान नहीं है आपका लगता है actually I don't have because of some reason my one laptop is not working, so I'm actually not able to watch the comments simultaneously, so that is why I'm not able to read your comments on time. Okay, so now my dear students, let's solve some questions and let us see how many of you is able to give the right answer. Okay, so what is the answer for this question? The volume of the charge that can be available in the engine after the suction, if the clearance volume is 20 cc and swept volume is 300 cc. Consider the mechanical efficiency and volumetric efficiency of engine as 90 and 80% respectively. What will be the answer for this question? Yes, it's a very easy question, simple question. The volume of charge that is available in engine after suction. After suction, what is the amount of volume available inside the engine? That volume is actual volume. They're asking you to find the actual volume in this question. See, these type of questions just given to confuse you. Why? Because they have given mechanical efficiency. No sense, no requirement of mechanical efficiency here. Okay, you know that volumetric efficiency is equal to, actual volume divided by swept volume. See, after suction, what will be the volume inside the cylinder? That will be actual volume, right? So volumetric efficiency is given, that is 0.8. Actual volume you have to find. Swept volume is given 300, that will be directly giving you 240 cc. So actually they are asking what is the amount of actual volume which enters inside the cylinder after suction. Because they have already given the swept volume and the clearance volume, right? So they want to know the actual volume. Actually, Shahat has given 240 and Nitish Kumar has given D. Okay, the answer will be option D. Okay, Ashura has given C. Okay, yes, I can see some of the students have given option. Ramesh Mohan has given option A, 288. No, that is not correct. Yeah, only volumetric efficiency is required. That is correct, Divakar. Ashwini has given option D, exactly correct. Very good. Next question. An IC engine having 6 cylinders works on Otto cycle. It has a bore of 20 cm and a stroke of 40 cm. If the clearance volume is 9000 cc, then the compression ratio will be. Yes, come on, tell me the answer for this question. See, in this question they have given there are 6 cylinders, so try to be careful. The engine is having 6 cylinders, the bore and the stroke, that is the diameter is given 20 cm and the length, that is stroke length, is 40 cm. The swept volume is equal to pi by 4 into d square into L. You know this formula, but because they are giving 6 cylinders, my dear, so you have to multiply with 6 to find the total swept volume. I can not give you more than this hint. Sir, clearance ratio बता दो. Clearance ratio बता दो. इसकी जरूरत ही नहीं है. You can find it without clearance ratio. Ashwini has given option C for this question. Very good, 9.38. Shri Kumar has given D. Chandan has given D. Sarvan has given D. Okay. In the YouTube channel, app में भी हूँ मैं. Yes. Okay. Yes. Ashwini has given option C for this question. Varun Kumar has given option C. Yes, those who are there in the YT channel, please answer the question quickly. Naga Venkat has given option C. Very good. So the right answer will be, yes, Shivam has given options. The right answer will be option C for this question. I can see some of the students in the YT channel are not responding for this question. Okay. Are you solving this problem? The compression ratio is equal to Vs plus Vc by Vc. It is equal to V1 by V2. V1 is the total volume. Total volume is equal to this. Swept volume plus clearance volume. And this is clearance volume. So you have to find swept volume. This is pi by 4 into 20 square into 40 into 6. We'll be getting the swept volume. Okay. And if you divide this sept volume, that is whatever sept volume will be getting, what is the value of sept volume will be getting for this? Can anyone tell me? Yes. Can you tell me the value of sept volume for this? Let me see my calculation, what I have done. The sept volume was somewhat around, yes, 75398.2. It will be sept volume will be 75398.2 cc. If you just put this value plus clearance volume divided by clearance volume, will be getting 9.38 as the answer. Okay, so this formula is important for compression ratio. Next question. In an engine working on an ideal Otto cycle, the temperature at the beginning and at the end of the compression are given 300 Kelvin and 600 Kelvin. What will be the air standard efficiency of the engine? Consider gamma value as 1.41. Yes, what will be the answer for this question? Those who are there in the YT channel, if you like this session, please also hit the like button. Yes, Shubham, that is correct. Ashwani, that is 75360. Yeah, very close to that, exactly. Pranaya is correct. Very good, Venkat. Yes, come on, tell me the answer for this question. In an engine working on an ideal Otto cycle, the temperature at the beginning and at the end of compression are 300 and 600 Kelvin respectively. What will be the air standard efficiency of the engine? See, my dear, it is a very simple question. Do you know why I am saying it is a very simple question? Because generally you know the formula of efficiency of the Otto cycle as 1 minus R by gamma minus 1. But do you remember how exactly are we getting this formula? If you remember the derivation of that, you can easily solve this question. Yes. So Nitish Kumar is saying yes. What is the answer? I think in the YT channel, some students are giving the answer not possible without calculator. No, it is possible without calculator. It is very simple. See, you think that efficiency is equal to 1 minus R over gamma minus 1. But do you know how we have got this formula? Yes. Actually, we have got this formula by using this relation 1 minus T1 by 1 minus T2 by T1. Because we know that, sorry, 1 minus T1 by T2. Because we know that T1 V1 over gamma minus 1 is equal to T2 V2 over gamma minus 1. Because 1 to 2 process is adiabatic process. In Otto cycle, 1 to 2 is reversible adiabatic process. Okay, and for reversible adiabatic, you can apply this formula. So you can say that V1 by V2 over gamma minus 1 is equal to T2 by T1. Sorry, this is, yes. So compression ratio. So T2 by, this is, and so this is R over gamma minus 1 is equal to T2 by T1. So 1 by R over gamma minus 1 will be equal to what? This will be T1 by T2. So this will be T1 by T2. This is 1 minus 300 by 600. This is simply 50%. So you don't need to do that calculation. If you remember the derivation, how you have got the derivation, you can easily solve the question. Okay. Clear? So the answer will be option A. Ashwani, Naga Venkat, Rameshman, Varun has given option B. No, that is not correct, my dear Varun. Nitish Kumar has given option A. Saurabh has given option A. Hi, Sai Sankar. Very good evening. Welcome to the session. Ashura has given option A. Dheeraj has given option A. Yes, it's possible. Next question. The efficiency of the diesel cycle approaches to Otto cycle efficiency when cutoff is increased, cutoff is decreased, cutoff is 0, or cutoff is constant. When can we say that efficiency of diesel cycle approaches to Otto cycle efficiency? Yes, come on, tell me what will be the answer for this question. Yes, today we'll be solving the questions of thermodynamics, complete thermodynamics and IC engine. Tomorrow we'll be solving questions on refrigeration and power plant. Okay. So you are taking our previous year for the current question for most of the time. Efficiency of diesel cycle approaches to Otto cycle efficiency when cutoff is 0. Yes, the answer will be what? Jenny, Naga Venkat has given option B, very good. Ashwini has given option B, no, option C. Logan has given option C, Naga Venkat has given option B. No, it is not. Efficiency of diesel becomes equal to or approaches to Otto cycle efficiency. See, Otto cycle efficiency is this 1 minus R over gamma minus 1. Diesel cycle is 1 minus 1 by R gamma minus 1 into gamma RC over gamma minus 1 over RC minus 1, where RC is cutoff ratio. If cutoff ratio somewhat becomes 0, in that situation the efficiency of diesel will become 1 minus 1 by gamma R over gamma minus 1. See, if you calculate this efficiency with using same compression ratio, the efficiency will almost become same, comes out to be equal to Otto cycle efficiency equal to 1 minus R over gamma minus 1. Almost become same. Okay, not exactly, but approximately it will approach to Otto cycle efficiency. Okay, next, if the maximum pressure in both air standard Otto and diesel cycle is same, then the relation for compression ratio and efficiency between the two cycles are, if the maximum pressure in both the air standard cycle is same, then the relation for compression ratio and the efficiency between the two cycles are, yes, tell me. Come on, tell me. Sachin Singh. Okay, Sachin Singh, if you are enjoying the session, then please also take out some time to like the session, and also please share the session. Okay, if you think that any one of your friend is preparing for Vizag Steel, then please take out some time to share this session also. Okay, if not before the session, then please after the session. If the maximum pressure in both the air standard Otto and diesel cycle is same, then the relation for compression ratio and the efficiency will be, maximum pressure is same. Okay, in that situation, which cycle will be most efficient, Otto or diesel? It will be, yes, come on, tell me. If maximum pressure is same, so if you see the Otto and diesel cycle diagram, this is Otto cycle. So can you tell me what is the maximum pressure in the Otto cycle? This is the maximum pressure. This is the maximum pressure. 1, 2, 3. Okay. And in the case of diesel cycle, the maximum pressure will be this. The maximum pressure is actually this. The maximum pressure is P3. And this P3 is equal to P2 actually. So my dear students, if you remember that if maximum pressure is same, in that situation also the compression ratio of the diesel will be more than the compression ratio of Otto. Compression ratio of diesel is somewhat around 16 to 20, while for Otto it is around 6 to 10. Okay, and the efficiency of the diesel will be more than Otto in that situation. The answer will be option A. Very good, those who have got option A. Very good for this question. Next question. A fictitious pressure that if acted on the piston during the entire power stroke would produce the same amount of net work as that produced during the actual cycle is called. Yes, I can see in the YT channel their number of students are reducing. I can understand. Diesel has higher compression ratio, exactly correct. That is what I am telling you, Ramesman. Diesel cycle will be having more compression ratio. Okay. Yes, what is that pressure called? Of fictitious. What is the meaning of fictitious? The meaning is hypothetical. It is also called hypothetical. Something which is hypothetical or imaginary. Or imaginary pressure, if acted on the piston during the entire power stroke, would produce the same amount of net work as that produced during the actual cycle is called mean effective pressure. It is called hypothetical average pressure or mean pressure that acts on the piston throughout the power stroke. And that mean effective pressure is equal to net work divided by sept volume. This is also the formula which you have to remember. Okay. So maybe in the exam they can ask you to find what mean effective pressure. And they can give you the net work output and the sept volume. So you should remember the formula also, what is mean effective pressure. Yes, come on everyone, tell me the answer for this question. I can see in the YT we have around 19 students and in the app we have around 15. So that means some of the students have left for They have left for their dinner. See, I have also not had my dinner, so I will be also having my dinner after the lecture. Okay, so could you please take out some time to be with me till the for next 15 minutes, for just next 10 to 15 minutes, so that we can wind up the session. So it's my request, do not go anywhere. We'll be solving some more questions of IC engine. A 4-stroke reciprocating engine has cylinder diameter of 4 cm, stroke length of 7 cm, and clearance volume of 2 cm. The engine capacity. Engine capacity we can sometimes call cubic capacity. Cubic capacity or engine capacity is equal to what? It is equal to swept volume. Okay. So tell me what will be the swept volume in this situation. दिमाग काम नहीं कर रहा है. Hi Ankit Jaiswal, very good evening. Welcome to the session. Yes. Ashwani has given 352 as the answer for this question. That is option D. Yes, everyone try to solve this problem. Swept volume is equal to what? Pi by 4 d square L. It's very simple, my dear. It is pi by 4. Pi by 4. See how I will be solving this question. Pi by 4 into d square. D means 4 square into 7. 4 to 4 will get cancelled out. So it will be pi. Pi is 22 by 7 into 4 into 7. This 7 and 7 will get cancelled out. It will be 88. So this is the engine capacity. Okay. So it will be 88 cubic capacity. But I think there's some mistake here in the question. The engine capacity, they have given a 4-stroke engine. Stroke length is 7. I think there's a mistake given in the question. Yes. What will be the answer for this question? The cubic capacity is equal to 88. It is a 4-stroke engine. It is a 4-stroke engine. So is the cubic capacity going to get affected by the 4-stroke engine? Okay, tell me. Is it going to affected by the 4-stroke engine? Actually, I think there's something missing here. I think it should be not 4-stroke, or it should be 4-stroke and 4-cylinder. It should be 4-cylinder also. It should be 4-stroke and 4-cylinder. Okay. So I think there's some option which is missing. It has to be written 4-cylinder. Okay, 4-cylinder has a cylinder diameter and all that. So it will be multiplied with 4. You'll be getting 352 cc. Okay. So I think this 4 is missing. It consists of 4 cylinders. A diesel engine has a compression ratio of 14 and cutoff takes place at 6% of the stroke. The air standard efficiency will be. Yes, what will be the answer for this question? Diesel engine having compression ratio of 14 and cutoff take place at 6% of the stroke. The air standard efficiency will be. What will be the answer for this question? Come on everyone, quickly tell me. Yeah, 4 cylinders should be there. There was a mistake in the question maybe. The number of cylinders has to be given. It has to be 4 cylinders actually. Very good. Yes, a diesel engine having compression ratio of 14. Compression ratio is 14. What is the meaning of cutoff take place at 6% of stroke? What is the meaning of this statement? Yes, it is cutoff means V3 minus V2. This is called cutoff. It is equal to 6%, 6 by 100 of stroke. Stroke means V1 minus V2. This is equal to stroke. Okay. So this statement is very important. Because from this statement, if you divide by V2, this will be V3 by V2 minus 1 is equal to 6 by 100 of V1 over V2 minus 1. Now V1 by V2 is equal to compression by ratio. This will be 6 by 100 into compression ratio is 40 minus 1. This will be 13 into 0.06. Okay, so this will be around 0.78. So this is cutoff ratio minus 1. This cutoff ratio will be 1.78. Cutoff ratio is 1.78, compression ratio is 14. Now, I would advise you, all of you, that if this kind of question comes to find the efficiency of air standard cycle, which is this formula, then leave this question. Leave this question immediately, because you are going to kill your time in solving this type of questions. They will give you these type of questions to find the efficiency of diesel cycle. Because it is not possible. It will take some time without calculator, obviously. Okay, if you have done good practice, maybe you can solve, but it will take some time. So try to avoid these type of question. Although the answer will be option B. If you put all the values of compression, cutoff ratio and compression ratio, you will be getting option B as the answer. But I would advise you that if the question comes like that, then leave the question, because unnecessarily you are going to spend your time in solving this kind of questions, which obviously you won't be able to solve without calculator. Yeah, or you can remember that, or you can remember the range of efficiency for compression ratio for Otto cycle. You can remember the efficiency directly. Okay, sir. Good night, Ashwani is saying. So, for example, for Otto cycle, you can remember the direct formula for efficiency uh, for compression ratio of 5 and 6 and 7. Similarly, same applies for diesel also. Okay, then only you can solve the question. Without calculator, it is not possible. What is the answer for this question? The answer will be dual combustion. The high-speed compression ignition engine operates on dual cycle or dual combustion cycle. Okay, next question. An IC engine works with a compression ratio of 16. If the cutoff happens at 8% of the stroke, then the cutoff ratio of this engine will be. Come on, tell me. Come on, tell me quickly. So just 5 to 6 minutes more, then I will end the session. Okay. An IC engine works with a compression ratio of 16. If cutoff happens at 8% of the stroke, then the cutoff ratio of the engine will be. It's a similar question. Divakar has given option B. Okay, Ashwani, you have given all the options correct. Question correct. That is very good, Ashwani. Your preparation is really very good. Shivam has given 2.2. That is option B for this question. Divakar has given option B. In the app, in the YouTube, I can see Chahat has given 2.2, Nitish Kumar 2.2. Yes, everybody try to improve quickly. Varun Kumar has given option B. Very good, Varun Kumar. So the answer will be option B, 2.2. Sarat Lal has given option B. Ashu Rai has given option B. Cutoff V3 minus V2 is equal to 8% of the stroke. Right? So you can divide by V2. This will be V3 by V2 minus 1 is equal to 0.08 of V1 by V2 minus 1. This will be 0.08 of compression ratio 16. So this is 16 minus 1. So this will be 0.08 into 15. This will be around 1.2. So this is cutoff ratio minus 1. The cutoff ratio will be 2.2. Now there is one more formula. If you know the cutoff ratio, if you know the compression ratio, they can also ask you what is expansion ratio. Cutoff ratio is equal to compression ratio divided by expansion ratio. So maybe they can ask you to find expansion ratio in the exam. So you should remember this formula also. That cutoff ratio is equal to compression by expansion ratio. Okay. Next, consider the following statement. Detonation in the SI engine can be suppressed by. Detonation in the SI engine. Shahrukh, okay, what is the question? Will the session will end so that I will watch from first? Shahrukh, yes, the session will end very soon in next 5 minutes. And after the session will end, you can start watch the session from the start. Okay. But if anyone has joined the session in the YT right now, then you can also like the session and share the session. Okay. Detonation in the SI engine or petrol engine can be suppressed or reduced by retarding the spark timing, increasing the engine speed. See, detonation in the SI engine can be reduced by increasing ignition lag. If you can increase the ignition delay somehow or ignition delay period, then you can reduce the detonation or knocking. So how can you increase the ignition delay? By retarding the spark timing, by increasing the engine speed, by using 10% rich mixture, or using a fuel of high octane rating. The answer will be option C. All the options are correct. Very good. Okay, very good. Very good, Divakar. Yes, option B, Naga, very good. Rameshman, option C. Ashwani, option C, very good. Very good. Those who are there in the app, in the YT, everyone is giving correct answer. So the if you want to reduce the detonation or knocking in petrol engine, all these methods are correct. The process of increasing the mass of the charge introduced into the same volume of an engine is called. What is that process called? If you want to increase the mass of the charge introduced into the same volume of an engine in order to increase the power output. Suppose there are two options for increasing the power. One option is by having a bigger engine. The other option is by using a, yes, by using a device, and that device is called a, Divakar has given option B for this question. Ashwani has given option A. No, yeah. Nitish, Nitish Kumar, tell me the answer. Stop having a discussion in the chat box. Tell me the answer quickly. Nitish is giving option A. Ankit is giving option A. Chahat is giving option A. Shri Kumar option A. Very good. Varun Kumar option A. Divakar is supercharger. Shrikant, very good. The answer is supercharger. Yes. Supercharging is a method by which you can introduce more air, more charge inside the cylinder in order to get more power output without increasing the size of the engine cylinder. Okay. The purpose of supercharging an engine is to. What is the answer? What is the purpose of supercharging? Latest bikes are, yeah, latest bikes and see, nowadays bikes are using super turbo twin engine or twin charge. Twin charge means supercharging and turbocharging. Nowadays we are using both the types of things in the modern technology. Yes, what is the answer for this question? The purpose of supercharging of an engine is to increase the power output of the engine. Very good. The answer is option A. Good, good, very good. Next, Morse test is used to determine the indicated power of multi-cylinder engine, shaft power, mean effective pressure, temperature of the exhaust gases. What is the purpose of Morse test? Shah has given option A for this question. Quickly tell me the answer. Shrikant has given option A. Santosh has given option A. Ashwani has given option A. JCM has given option A. Satish has given option A. Morse test is used to find the indicated power for multi-cylinder engine. And sometimes maybe in your exam they can also give you mechanical efficiency and friction power. Yes, after you have found the indicated power, after that you can find the mechanical efficiency also and friction power. Okay, and in this Morse test, friction power remains constant for conducting the Morse test. Which method can be applicable to measure? Yeah, last 5 minutes. Okay, last 5 minutes. Okay, last 5 minutes. Let's solve the question of IC engine completely. Then tomorrow we are going to solve the question of refrigeration and power plant. Okay. Which method can be applicable to measure friction horsepower only for single cylinder petrol engine or CI engine? Which is the method used for that? Morse test, Williams line method, both can be used or none of these. Which method is used to find the, how much time? Only 5 minutes, only 5 more minutes, not more than that. Okay. Next, the answer will be, come on, tell me. Nitish Kumar saying option C. Both can be used. अरे भाई option तो देख लो, question तो देख लो. Single cylinder CI engine. Beta, Morse test is used for multi-cylinder engine, not for single cylinder. So the answer will be option B, Williams line method. Williams line method will be the answer. Why? Because Morse test is not used for single cylinder. It is for multi-cylinder engines only. Okay, so the answer will be option B. Try to read the question very carefully. Both by Morse test and Williams line method, you can find the friction power. But if it is given single cylinder engine, then Morse test will not be applicable. Okay? An engine consumes 5 kg per hour of fuel and its brake power is 20 kilowatt. The value of brake specific fuel consumption is 0.25 kg per kilowatt hour. Single देखा नहीं, यही तो mistake होगी बेटा. This is the kind of mistake that you might can commit in the exam. So I don't want any one of you to do this mistake. Okay. specific fuel consumption, the brake specific fuel consumption will be equal to option A. Brake specific fuel consumption is equal to mass of the fuel divided by brake power. Very simple. Okay, so the answer will be 5 by 20. It is equal to 0.25 kilogram per kilowatt hour. So you have to remember the formula for brake specific fuel consumption also. Okay. How do we get previous year question of Vizag Steel? Ankit, previous year question of Vizag Steel are not directly available in the online or in the Google. But if you will do a search on that, you will definitely get some few questions of Vizag Steel MT conducted in 2017. But it is very rare because around 100 previous year questions are there from Vizag Steel from all the subjects. Okay, so I think Vizag Steel MT exam is going to be conducted this time, and you can take reference of previous year question also. Yes, the answer. Last question. Okay, let us take this as last question. Then we'll solve rest of the questions tomorrow. Okay, let us take this as our last question. In a Morse test on a two-cylinder, two-stroke SI engine, the brake power is 9 kilowatt. And the brake horsepower of the individual cylinder with the spark cutoff are 4.25 and 3.75 kilowatt. You have to find the mechanical efficiency of the engine. Yes, Shahat has given 90%, Sailor Vivek has given 90%, Sarvan has given 90%, Gangadhar has given A, Rameshwan has given A for this question. No, it is not wrong unit, my dear. Kilogram per kilowatt hour is the unit of specific fuel consumption. It is the unit of specific fuel consumption. Okay, so it is not wrong, Ashwani, my dear. What will be the answer for this question? Chahat? Yes, PSC question. Previous year PSC question definitely will help in this exam. That is BHL and other PSC questions can also be, you can practice those questions also. So what will be the answer for this question? The answer will be option A, 90%. How can you solve this question? See, the brake power of all cylinder working, that is two cylinder working, is equal to 9 kilowatt. The indicated power 1 will be indicated 1. That means when one cylinder is cut off, when first spark plug cut off is equal to brake power of all cylinder minus brake power of first cylinder cut off is 9 minus 4.25. We'll be getting some value here. Indicated power of second will be equal to brake power of all minus brake power of second cylinder cut off, that is 9 minus 3.75. You can solve these two values. You will find the total indicated power will be equal to I1 plus I2. And from here, you can find the mechanical efficiency after finding the total indicated power divided by the brake power. So brake power is given, this you will be getting 10 kilowatt. This is 10 by 9. Sorry, that is indicated power. This is 9 kilowatt. So how much is the how much is the indicated power you are getting? Tell me. Let me see my calculation also. Yes. Sorry. I think my brain is also not working right now because it will be brake power by indicate power. Okay, so that will be 9 by 10. It will be 10 kilowatt. So that value will be equal to 4.75. This will be 4.75. Okay. And this will be 5.75. And total will be 10 kilowatt. So that will be 90%. Okay, so that was the last question for this session. Now, before we wind up the session, I have to tell you that tomorrow also we'll be solving few questions. I think let us take this as our second last question because you know that sometimes you feel greedy to solve some more questions. Which of the following valve is provided for starting the engine manually during cold weather condition? These are miscellaneous type of questions that can come in the exam. Which valve is used? I think that you might have also used these type of valves. You must have used that valve also for starting your petrol engine during winter, especially during winter when this cold starting problems are there. That valve is called as choke valve. That is called choke valve. My mail ID is vikas.bhadoria. If you want to contact me anyhow, you can contact me through my mail ID vikas.bhadoria @gradeup.co. Okay, it is vikas.bhadoria @gradeup.co. Okay. Next question. Okay, so that was all. This was the last question of IC engine. Tomorrow we'll be solving the question of refrigeration and power plant. Okay, at 7 p.m. So before we wind up the session, I have to tell you about these three courses. I think these two courses, Gear Up and Rank Up, if you have already joined, that is good, because now the time is not left for these. Maybe for this session, if you want to join, you can join our Gear Up and Rank Up course also. But nowadays, the only course which is important is Vision 2022, which I think might be useful if anyone is preparing for GATE and Engineering Services 2022 in next to next year. Then you can join our Vision 2022 paid course. It is a paid course for GATE and Engineering Services 2022 exam. This course is ideal for BTech second year and third year students. For more information, you can give a call on this number. And these are the faculties who will be teaching in these paid courses. Okay, this is a list of the faculties. This is a list of our toppers who have got very good marks. They have got selected in the GATE and Engineering Services previous year exams. So you can take inspiration from them. You can also join our paid courses. Okay. And if you have not taken Gradeup Super, then Gradeup Super, it's very important for everyone. You should also take that. Gradeup Super gives you access to all our paid courses with just one subscription. Okay, you can have an access to all our paid courses and also to our Gradeup Green Card. So you can also take our Gradeup courses. One more thing, we are having our Gradeup 5th year anniversary sale. On completion of 5 years of Gradeup, Gradeup is offering you this 5th year anniversary sale, in which from 26th to 30th of November till Monday, you will be getting discounts on our paid courses subscription on all our paid courses on 2 years. On 2 year courses, you will be getting 40% discount. On 1 year course, you'll be getting 30% discount. And on 3 months course, you'll be getting 20% discount. So if you want, you can see this discount is only applicable from 26th to 30th of November. So if you take any paid course of Gradeup from this interval, you'll be getting this much amount of discount. Okay. So thank you so much for joining me for this session. I have enjoyed a lot with you guys, and I hope to see you tomorrow. That जो भी बच्चे आज आए हैं, I wish to see everyone tomorrow at 7 p.m. Tomorrow the class will be at 7 p.m. Okay, so that is the timing. AAI एग्जाम बता दीजिए. एयरपोर्ट अथॉरिटी ऑफ इंडिया, उसके लिए भी आपको बेटा तैयारी करनी पड़ेगी. यू हैव टू प्रिपेयर. Okay, Varun Kumar, and you have to solve technical as well as non-technical questions. Okay, for Airport Authority of India. Please try to conduct the class of NLC answer key. Saurav, tomorrow I have 3 classes, so I will plan, my dear. Okay, I will definitely plan. I will talk to my team regarding that. सर इन सभी की PDF दे दो. चाहत PDF तो बेटा YouTube में नहीं हम प्रोवाइड करते, but yes, we'll try कि इसका PDF आपको प्रोवाइड करते हैं. Okay, I will try that. Okay, definitely I will try that. Okay. So thank you so much everyone for joining me in the app as well as in Gradeup YT channel. I enjoyed a lot today with you guys. Tomorrow also we'll be having a wonderful class like that tomorrow at 7 p.m. Tomorrow timing will be 7 p.m. Vizag MT Thermodynamics practice session part 3 will be tomorrow at 7 p.m. Okay, so कल मिलता हूँ आप लोगों से शाम को 7 बजे. I will see you tomorrow at 7 p.m. tomorrow. Till then, take care everyone. And if you like this session in the YT channel, please also like the session, share the session. And if you have not yet subscribed the channel, then please do subscribe the channel and press the bell icon also. Course start कब होगा? Okay, Varun Kumar, I don't know whether we are planning for some courses for AI. I will ask my team regarding that, whether we are planning some courses for Airport Authority of India. Okay, and I will let you know. Okay. Mail कर दोगे? Yeah, definitely. So mail is not possible. I cannot do personal mail, but yes, there is a Gradeup Telegram group. You can join Gradeup Gate Telegram group, and in that Telegram group, I will share the PDF. Okay. So thank you so much for joining me. That was all, and it was very wonderful session, and I was very happy to meet you all in this session. I'm also hoping to meet you all tomorrow at 7 p.m.